So before we can start making any parts with any kind of precision or boring or reaming or anything like that, what we need to do is true the lathe. A lot of people will level their lathe and then they true the lathe using the tailstock method. And that's really only about 2/3 of the process. There's a step and sometimes 2 steps in between there that are absolutely critical to producing any kind of parts with any kind of precision at all. And that's what we're going to go through, and that's what we're going to talk about in this video. So we have our machine, and hopefully you've got leveling feet. If not, you're gonna have to use shims or some way to level the machine. And what you'll have, if you have the leveling feet, or most machines, you'll have 6 adjustment points. You'll have two adjustment points at the tailstock end. You'll have 2 adjustment points on the inboard portion of your headstock. You'll have 2 adjustment points on the outboard portion of your headstock. And what we're going to do is we're going to talk about how all of these relate to each other, because I get a lot of questions on this. And this is how I've done it, and this is what works very well for me. So my first 2 adjustments are going to be using the tailstock and the inboard feet of the headstock, and that's what we're gonna be leveling here and here across our bed. And what we want to achieve is we want to get all the twist out of our bed. Once we do that, this is where it gets real interesting, and you'll hear people talk about bows and sags and all of those things. I don't worry about bows and sags because I kind of know what's causing it, and it's really not that the bed is bowing or sagging. What it is this adjustment has to do with this adjustment on the outboard of our headstock. And what that will control is the nod of our machine, which will be perceived as a bow or a sag. If the outboard feet are too low in relation to the level of our other feet, it's gonna lift the spindle this way. It'll lift it up, and that'll be perceived as you're turning as a bow in the bed. If they're too high, it's going to push the spindle downward. That's going to be perceived as a sag in the bed. We want it true. We want our headstock as true as we can possibly get it in relationship to the bed. There is another adjustment on these machines. I'm going to talk about it. I hope we don't have to mess with it, because it is a kind of a time-consuming deal. But most modern gearhead machines also have an adjustment on the headstock, very similar to a tailstock adjustment, to control the alignment of the spindle bore in relationship to the bed. I.e., if your bed is 6.5 inches wide here, 6.5 inches wide there, we need the center of our spindle to be straight down the center of our bed. And there is an adjustment to accomplish that. The only time that I've ever really run into that is on older machines that have some wear, or they were slung wrong when they were moved, dropped, which usually that can be pretty catastrophic all the way around, or it took a crash of significance, or it's just been crashed a bunch. Anyway, that'll show up in a taper. Usually if that's out, you'll have trouble. Well, if any of those adjustments out, if the knot is out or the spindle alignment with center to the bed is wrong, that will show up in your finish. It'll show up in your parting. That parting blade will grab and you'll be breaking parting blades. Threads will have chatter. All of the, nothing good comes from that. You'll be cutting on tapers. We don't want any of that. So that's what we're gonna go through on this machine. It's pretty cold out, and I've already done this. You heard me talk about that before, but it is cold this morning in the shop, so it's gonna be out. In fact, this is the process. I go through this process before I do anything that requires any level of precision. If I'm just making Farmer Brown parts, I'm not too worried about it. But if I've got to really be dialed into, tenths, pretty much anything less than a half a thou, I'm going to go through and check the level on my machine. Once you get through the initial setup, pretty much the only thing that I've ever had to worry about after that is just make sure that the bed is in alignment, or the bed is level. Once this is set and the tailstock is set, that is all relative to the bed. So when the bed is aligned, everything else should fall into place. Classic example. If let's say I've trued up a receiver, and I'm getting ready to do my barrel work, and I know I'm not going to have enough time to do my barrel work, I don't even set the barrel up. I'll save it for the next time, because that is going to be, it's not going to be the same. In the same sense, I make sure that I finish those operations that day, and I constantly double check that throughout the operation. That way I know that everything is as accurate as possible. So all that being said, I think it'll make a lot more sense when we start going through the process. So let's take a trip over to the bench and we'll look at some tools and materials that you'll need to true your lathe. Tools we're going to need to accomplish this feat is we're going to need some basic hand tools to adjust our leveling feet. Hopefully you're using leveling feet. You're not going the shim stock method. That is a really laborious exercise. Next, we're going to need a level to actually level our bed. Now you can rough it in with a carpenter's level, but you really should have a machinist level, preferably one that reads in at least 5/10,000ths per 10 inch. That's what I'll be using today. Ideally, which is what I went through originally, is 5/1000ths per 12 inch. You'll need a flat surface to calibrate your level. Even though it's brand new, you definitely want to check it for level. If you keep your level in area that is a different temperature than where the machine is, you definitely need to calibrate the level in the area where the machine is. Temperature does affect these things, and we'll go over how to do that here shortly. You'll need a flat surface to accomplish that on, be it a clean drill press table or a relatively flat bench. I'll be using my Starrett Precision. This is a precision ground surface plate. This is granite that has been ground pretty much as flat can be. I can't remember what the grade this is, but it's pretty true. It's definitely flat. I don't think you need to go that crazy, but something that's flat that we can spin our level 360 degrees for calibration. You'll need some parallel bars, preferably matched sets. Don't get a bunch of mismatched sets because they could be different heights. You'll see I have 3 different sets here. One, you'll need a set to calibrate the level. And then the big thing with these is it gets us above the V's on our lathe. Those V's are different heights. So we need to get above them to be able to set our level. From there, we're going to need a micrometer, preferably 2-inch or better. And preferably one that reads in 10,000ths. This is a Mitutoyo 1 to 2, and this is HDT 2 to 3. Both of these are very accurate. They're accurate to 10,000ths of an inch. That's the resolution on these. You can tell that by if you're 1,000ths on your spindle, you'll have this set of numbers and the numbers on your thumb wheel. You will not have these graduations along the barrel. These are the 10,000ths here. Definitely want to get down into 10,000ths for this operation. A dial indicator will be handy. I'll be using the Grizzly 10,000ths dial indicator along with Mitutoyo 5/10,000ths test indicator. At the bare minimum, you'll need a test indicator that reads at least 5/10,000ths and a good set of dial calipers in place of the micrometers. Really should use the micrometers. This is a Mitutoyo Digimatic. This is an older set. These are very, very accurate down to a 1/10. You'll need just some round stock, preferably, really in this case, bigger is better. When we go to make our test bar for the headstock alignment, we don't want to have any deflection. This isn't being supported by anything, that's the point. And so, 2-inch or better, 6 inches long or so would be great. 5 to 6 inches long would be great. This is the one that I had originally used, so I'm going to go ahead and use this again. Along with that, we're going to need a Sharpie, some acetone, which is not on the bench, and then if you don't trust the spindle bore of your tailstock, you'll need a dead center or something that has a known good round surface to indicate off from. If you've got a good spindle bore on your tailstock, you can dial right in off of that. You'll also need a mirror because we're going to be reading the front, bottom, back of the machine on the indicator, and you won't be able to see those, so a good little mirror will help achieve that. And at last, some shop towels. We really need to make sure that the machine is clean when we do this. I've seen one little tiny chip really screw with this process, so we want it clean. That being said, I think that's pretty much everything. Let's head over to the machine and start this operation. So we need to calibrate our level. Now, you do need to have a flat surface. It does not need to be a level surface. We will find every unlevel surface has a level point, and that's what I'm going to show you. This is a good way to calibrate your level. You will need some good heavy parallel bars so you can mark the location. So hopefully you can see the bubble on the level. And you'll notice that we are not level. So what we'll do is, on a clean surface, this block has been wiped down with Windex, rubbing alcohol, vinegar. Those work the best. I really like, if you're using a surface plate, I really like the Windex, just seems to work the best. But what you want to do is we're going to turn our level around the surface plate until we start coming into level. You can see we're close. Now we've moved the bubble from this end to this end. You want to let these move very, very slow. So you want to let that bubble settle. And I'm just going to very carefully bring this into perfect level. I went too far there. And take your time doing this. So right there is perfect. Now I don't know what you're going to see in the camera because we're going to have a little bit of distortion, but from my perspective, looking straight down on the level, it is perfectly level. So the next thing we're going to do is we're going to take our gauges and we are going to mark that spot out, being very careful not to disturb our level. And you can see I disturbed it. So we'll bring this back into level, just a little bit more. That's good. Make sure we're still good. Let that bubble settle, give it a minute. Okay, so we're back where we should be. So then what you want to do, without moving your parallel bars, we're just going to flip our level 180 degrees and get that back into position and see where we wind up. And you can see that we're basically out a 1/1000th of an inch. Now most of these levels will have an adjustment screw, and so what we will do is, which I forgot to mention in the materials list, you will need a screwdriver to make that adjustment. We'll get our screwdriver and we'll very carefully adjust this back to where it's level. And the way I do that is I go about half the distance. And then once you get your measurements to where they read the same, we'll very carefully find level. We'll mark everything with our gauges again. And we've confirmed level. So you want to just keep doing this until you get your level. Hopefully you can see that. There's probably a little bit of angular distortion just because of the angle of the camera, but when you look straight down at your level, it should be perfect. I'm just going to verify one more time. That's what you don't want to do, because just that little bit of a knock could have threw our level off. We'll try to do this a little more carefully. There, that is perfect. So from here we can go get set up on our lathe to get our bed level. So I'm really going to try to make this as painless as possible. We've got a lot of moving around to do. So I'm going to do some editing from moving the camera from point to point, just so y'all don't get seasick. I don't like watching that stuff any more than anybody else does. So we're over at the headstock, and what we want to do is we want to set our parallels on the bed. And what you want to do is you want to keep all of this the same. So what I'm going to do is I'm going to mark an F for front, a B for back. I'm going to put an arrow so I know which way they face, and then I'm going to draw a line on the bed so that I know that I can put these bars back in the same position every time. So I'm going to want to do that on the headstock side, and I'm going to want to do this on the tailstock side. And I'm going to remember that these, obviously I can read them, and that this is how they face. So these have to be the same. One other thing that I'll do before we go to the tailstock side is I'll place my level on the block, so make sure I get a good 90 degrees. And actually I'm going to screw the lathe up a little bit because it's actually level. I was hoping that it'd be enough of a temperature swing between yesterday and today that it wouldn't be. But I'm also going to draw a couple lines so that I make sure that my level goes in the same place. And you'll see I'm making just a little cross right here up the side of the level and across the block. That way I can line this up end for end on the headstock side and the tailstock side, and I know that my level is going to the same place every time, because it will make a difference, and it'll drive you absolutely crazy if you don't do that. If you have a set of parallels, another set of parallels, you can just use two sets of parallels. Just mark where your level is located so you can index to the same point. So what I'm going to do is I'm going to swing down to the tailstock side, and I'm going to get that cleaned off. You want to make sure that your lathe is really clean. Make sure that bed is really clean. You don't want any oil, any chips. So wipe it off real good with a rag, maybe some acetone, and then once it dries, wipe everything down with your bare skin. Your finger, your skin will pick up all that dust and debris, that microscopic stuff, and you're gonna give your lathe the best shot at being level as you can. So let's head down to the tailstock and we'll get set up down there. So you can see I've got my bars set up. I want to get on a 90 degree, and I'm going to line the little T's that I made on the edges. And then I'm going to do the same thing. I'm going to draw some index lines right on the bed of my lathe. So I know that I can align I can get my level to the same place. So I've got a much better shot of repeatability this way. Now, I did go ahead and sabotage the machine a little bit. Hopefully you can see that we are not level. We're out about 5/10 thousandths. So we're going to go ahead and bring the tailstock into alignment. And the way I do that is I'm going to adjust that foot right there. So this does the tailstock. This does the level on our headstock. This one right here. On the headstock side of the bed, I should say. This foot right here, I'm just going to keep up with that. But that is what's going to adjust our nod if we need to. We'll show you that in a minute. You don't want to make big adjustments here. I'll try to stay out of the way. I can't see where anything is up there because we're dealing in 10 thousandths, so it doesn't take a lot to get a lot. I need to bring this end up. I just go a little bit at a time. It's a lot of up and down. Just a little. Little adjustment, just a little bit more to go. And when you're first there, that's perfect. When you're first doing this, people always ask me what feet. I just try to alternate. I don't want one set of feet with 3 inches of adjustment and the other set with none. I want to kind of disperse that equally as the best I can. Preferably keep everything kind of as low as possible. Mine are set up a little bit higher just because I'm a little taller. That was a little too much. And just remember to allow that bubble to settle. Give it a little bit of time. Almost perfect. I'm probably fighting with a tenth right now. I'm right in between hash marks. There we go. That is perfect. I'll bring you in, so hopefully you'll be able to see this. So hopefully you can see that the bubble has moved and we are level. That's this way. Across the bed this way, I don't worry too much about as long as everything's on the same plane, because a lot of that depends on if you have a coolant pump, where the drain is located, and if they built slope into your pan. On this level, the drain is on this end of the machine, and they did not build slope into the pan. So I want it I want the headstock a little bit uphill, just a little bit. It's really, this needs to be on the same plane. And then if you think, and I'll show you when we get into adjusting the nod. If you think from the center line of the spindle to your bed as a triangle, you really want all of those to be equal. That, you know, if you know, here comes a shot math or trig, but that's basically what we're dealing with is a triangle. We don't want like this, we don't want like that, we want it just like that. And that's not going to matter on this level, if you follow me. I'll talk about that when we get to it. Let's go down to the other end of the bed and we'll get that leveled up. Okay, so again, I'm going to make sure that my back bar goes in the back and that I get that lined up with my index lines. So I can get relatively close to where I was before. We'll get my level in position. And I am out about a tenth down here now. So when we started, we were dead level, and now we're out about 5/10 thousandths. So we'll go ahead and get this end brought in. So I'll be leveling on this foot here. If there's real huge adjustments where this one comes off the ground, this one here, then I'll just make sure that that pad is on the ground, but I'm not going to do a whole bunch of adjustments on this end yet. So it looks like this side needs to come up or the back side down. This is such a minute adjustment. I'm going to work from one side of the machine. So this just needs to come up 5/10 thousandths. That may have been too much. Well, no, I'm going to have to, pretty close. Okay. I'm going to have to step in front of the camera here just to check, and we are spot on. So we'll bring you in. We'll bring you in so you can see that. Hopefully you can see that we are now level. Now what we want to do is we want to go back. So now what we want to do is whatever affects this end, it affects the other end. So we're just going to go back to the tailstock and verify that that didn't move. Sometimes you got to go back and forth. When you're initially setting this machine up, it's a lot of back and forth. Stick with it. And in those cases, I work off diagonals quite a bit. If I bring this side down, I'll bring the back corner on the head stuck up rather than the front down. If that's where I need to go. I worked opposite corners. It seems to work a little faster, but when you get it really dialed in and you're dealing with very minimal adjustments, you can take that out on one side of the machine. If I had like 2 thousandths out, I would work my diagonals. Let's go down to the tailstock and we'll check our level. So I'm gonna have my front in the front, back to the back. Line them up. That wind's really blowing today. Get everything lined up to my marks. Get my level lined up. The other thing that these marks help with is making sure that you're not flipping your level end to end. It shouldn't matter, but you want everything to stay the same. Let the bubble settle. And we are off about a 1/2 tenth. Or a tenth in this case. This reads 1/2 thou. We've got about a 10,000th we got to deal with, and so I'm just going to play this game back and forth until everything is just lined up just right. We'll zoom out so y'all can just see the whole progress. Like I said, it's a lot of back and forth until it just falls right into place, and it does. So I'm a little bit low here, low in the front or high in the back. So we'll bring this up just a tick, just a very, very small amount. That is pretty close. Right there is perfect. We'll go down to the other end. And I'll bring y'all in and show you what it looks like. Like I said, I don't really know how much parallax is what you call that, angular distortion. When you're not looking at something straight on, you'll see in the video. And that's why it's very important when you're doing this on your machine to line everything up as close to exactly the way it was originally set up. If you're lucky and you buy 2 of everything, you don't have to do any of this. I'm going to let everything settle. This side has to, where'd my little wrench go? Looks like it needs to come down. And what I'm probably going to do is start just where it's kind of the same 2 adjustments. I'm going to work corners now, so I'll bring this down, and if that side's still out, rather than going up on the front, I'll go down on the back side. It just, to me, it works a little bit faster that way. Just a little bit more. Make sure I don't. Now see, this is where I've also got to take some pressure off this leg, because it's sitting right on it. That may be what that's what I was battling. So that's what I mean by keeping up with your adjustments. Right now I have to bring it up about 1/10. Just right there. Probably just right. That's perfect. Come back to the tailstock side. Make sure my bars are just right. And this is good preparatory work for dialing in barrels and things like that, because it's just a lot of doing the same thing and splitting frogs' hairs over and over and over again. So now we are spot on, dead level. Hopefully you can see that is really good right there. And I'll take this and we'll go down to the headstock side. And hopefully you can see that we're spot on here as well. Hopefully I can get as much of this out of the way. So the next thing I want to talk about is, so now our bed is level. And most people from here, they'd go through the truing bar and the tailstock and make sure that the tailstock is in alignment. We really don't want to do that. What we want to do is we want to turn a test bar that is supported only by the headstock. And what that tells us, and this will demonstrate hopefully that triangle that I was trying to explain in a much better way. So what I'm going to do is I'm going to open up the 6 jaw. You don't need to have this stuff, but this is for just for demonstration purposes. I'm going to get a piece of ground rod. And so this is a representation of our spindle bore. We know that our bed is level here. We know that our bed is level here. That's this way. So as long as our spindle is not pushed over this way, pulled over this way, or pushed up or down, it should cut a true part. And you can kind of see that triangle that I was talking about now, from here to here, up. Now, that's just how that's how I look at it. It is just I see that triangle, and to me, if I've got an old lathe or whatever, this was turning a part that was conical, i.e. wider out here, narrower here, that would tell me that everything is pulled this way. It's pulled the work. I've pulled whatever it is I'm turning into the cutter, and as I go to the headstock, the part is getting further away. I hope that makes sense. I probably should have used that dowel because I could really bend it. But basically what it is this distance would be less than this distance, and the angles would be different. That's getting into a whole bunch of stuff we don't need to worry about. But I think it's a good way to visualize that, is we want a really good symmetrical triangle, i.e. the distance from the center of this part to the bed should be the same as the center of this part to this side of the bed, if that makes sense. If it's not, we're going to turn a cone. So once that's done, then we need to worry about the nod. That's the up and down. So one way we're measuring this way, the other way we'll be measuring this way. And so if I turn my part here and here, and they're not on the same plane, that's going to tell me whether I'm sagging on the outboard side, on the adjustment feet. Those would be set too low, which would cause the bar to angle up. If it's too high, it's going to angle the bar down. That's what we're going to work. That's what we're going to test out next. Hopefully, and I may, since I do have that adjustment foot backed off quite a bit, we're going to see that in the test bar. So let me get set up and I'll show you what we're talking about there. As far as the blue lines that we've wrote all over everything, that's what the acetone is for. That'll wipe right off with a little bit of acetone. So our bed's level. Now let's go ahead and make sure that the center of our spindle is actually in the center of our bed. Hopefully it is. And then we'll check the nod of the machine. So it doesn't much matter whether you're using a 3-jaw, 4-jaw, or 6-jaw, or how true it is, because it's going to turn concentric to the spindle no matter what. What we want to make sure is that these dimensions match these dimensions. And so that's what we're going to do now. So before we can do our test bar, chances are you don't have any tooling set up for your machine, or you wouldn't be leveling it. So a quick, easy way to do that is you can use a good dead center, either preferably in the spindle using your spindle adapter, or in the tailstock. That'll give you a good, it'll get you pretty close to the center, so that your tool height is on center with your spindle. A better way would be to actually make a height gauge, but you got to have some crude adjustment to be able to even do that. So there is going to be a little bit of distortion here, but I believe the way I have the camera set up, you can clearly see that this tool is significantly lower than the center line of our spindle, and that's indicated by the very tip of our dead center. So what we want to do is loosen this nut. Obviously you want to be able to have your tool holder slide up and down, and you'll bring that up or down whichever way you need to until you are, that's got to come up a little bit more, at the same height as the tip on your center. And then to check that, you do want to clamp the tool down. And I believe is pretty darn close. I think it needs to come up just a little bit more. There we go. You don't want to run the tool into your tip because you'll ruin the tip. But I think now it's just a little bit high. Let her down just a little. There we go. That's good enough for what we're doing right now. And then you can just lock the jam nut down, and then when I take this tool out and I put it back in there, it'll go to the same place every time. Again, a better way to do this to check your tool height is with an actual height tool, but we don't have any way to make that. Our tool, this is a brand new machine, our tooling isn't set up, so we have to get a rough set on our tool height. That's how you would do that. From here we can turn our attention to our test bar. So you have your test bar in your headstock. We don't want to turn this whole area because one, that's going to create a lot of heat, and two, it's going to take a long time. All we care about is a little bit over, maybe a ½ inch over here and a ½ inch over here. So what I do is I'm going to mark a line so I know what I'm turning to. So I'll just engage my tool until it just touches the steel and I get a line, and then I'll come down to the other end. And I'm going to do the same thing here. Scribe a line, and now I know what distance I'm going to hog out. So now what we're going to do is we're going to turn the machine on, and I'm going to remove, first I want a good clean cut all the way across the part. And then once I get a good clean cut across the entire surface of the part and around the whole circumference, I'm going to remove about 40 thousandths. Basically, I'm going to make a barbell. So what we are going to do is, this is going to be an unsupported piece when we actually cut the dumbbell portion, but when we hog out the middle, we are going to want to support that with a live center. So what I'm going to do is I'm going to go ahead, we're going to drill that out for a live center. So like I said, that's the only reason for that center, is just to support this while we hog out the middle portion of our test bar. So I'm going to go to my index mark. I'm not going to use cutting fluid. It'll just make a mess in this video. But basically, we want to turn this down until we had a good even cut across the entire circumference, the entire distance, which this should be pretty close. Making some, I could probably turn a little bit faster actually, and a little bit longer chip. So I've taken this down about 40 or 50 thou. And then from here, we can start checking out how true our machine is. Okay, so we got our roughing cut done. That cutter I got to replace, but like I said, it's not gonna much matter for what we're doing for this. The only thing we're worried about is the dumbbell portion. So I'm gonna change my cutter to a little bit different design, one that I know will cut a really good finish. I'm going to use, I'm going to try my DRO out on this, I guess. What I'm going to do is start the machine, and from here we're just going to turn down this little 1/2 inch and then a 1/2 inch over here, and these two parts need to be a very good finish. So that being said, we're going to take a 1 thou cut. And you want to do that until you get perfect cleanup. You can see it cut from here all the way to here, pretty much on both sides. So I want that to be true all the way across. I want a good cut all the way, the entire circumference on both ends, and then I'll have a good way to measure it. So again, we're going to take another thou. I can tell by the chip we still have a little bit. We're still not quite concentric, so I'll just go thou by thou. I think we're getting pretty close. We'll check here in a minute. Yep, still probably got one more thou. There's one little section right there. This side over here is already cut and clean. So that tells me, depending on how this measures, we've got something going on. It probably has to do with that foot that I loosened up. Go back and make a spring pass. Just in case we had any deflection. It doesn't look like we did. Make sure we have a good cut all the way around. We do. Get these chips out of the way. You kind of want to rock this a little bit until you feel the anvil bottom out. But you can see we are somewhere in between 2 and 3/10. Well, I don't know that you will be able to see that. Anyway, we're within a 1/2 10,000th between the two. I'm sitting right in between 1 inch 991 and 2/10,000ths and 1 inch 991 and 3/10,000ths. It's split. The line is splitting right in the middle. So it's got to be, you know, we're within a half a tenth. In concentricity, so that's outstanding. So what that tells me is that I have no twist in the bed, and my headstock is on the center line of the bed. The spindle bore is in the middle of our bed, i.e. we have a good triangle. So the next thing we'll do is we can hook up a dial indicator, and we can verify a lot of that, and then we'll also check the nod on the machine. You can use a test indicator. I'm going to be using my dial indicator just because it's a little bit easier for me. So you can see here, let me set this up so we're on 0. It's very, very sensitive. There's your 0. And then we'll come over, and you can see we're about a 1/10. So what I'm going to do is I'm going to split this. I'm going to raise this 1/2 a 10,000th, and we should get about the same reading. So I've gone back and forth a few times, adjusting that foot, which is gonna, those feet, to bring that nod in, and you can see our dial is sitting down to about negative 5/10,000ths or 95 10,000ths. You know, that's where we're sitting at the 5 10,000ths. And then we'll swing over to the outboard side, and we're sitting at 5 10,000ths. So now we know that across this span we are perfectly straight. Everything is concentric to the spindle bore now. So now the next step is I'm just going to go ahead and lock that nut down. And then just to show you, hopefully you can see trying to hold the camera as steady as I can, that our lathe is still perfectly level. So from here, we've got our bed level. We know that the center of our spindle is in line with the center of our bed. We know that the nod of our spindle is parallel to our bed. From there, we can go ahead and dial in our tailstock. Now, there's a couple of different ways to do that. I'm going to show you the way that I do it. You can go through the process of doing a truing bar, and basically the same thing as this. It's just you'll leave it supported on the tailstock because that's what's going to move the bar. You'll actually turn on centers. I prefer to do it with an indicator right in the chuck and just dial in off a good dead center, or if you got a brand new spindle, you can dial in right off your spindle. Either way, that's what we're going to do next. Okay, so now we're going to turn our attention to our tailstock. You can see I have my Mitutoyo 5/10,000 indicator set up in the chuck. I'm going to go ahead and bring my tailstock up, and I'm going to watch for deflection if I got any. That needs to be positioned a little bit. There we go. So that's good. I'm going inside the tailstock. I'm going to lock the quill down, and then basically what I want to do is I'm going to zero my indicator. What I'm going to do is we are going to adjust the x-axis on our tailstock first. This is X across the bed. Z is on your spindle alignment. So right now I'm 0 on this side. We're going to flip it around, and you can see I am about 5 thou out. So what I want to do is I'm going to split that difference. So I'm going to get my Allen key, see if I can get this to where y'all can see. So there's 2 little set screws down here in the tailstock. What I want to do is I'm going to loosen the back. And tighten the front. Make sure I didn't lose contact, which I think I did. No, I did not. Whoa. So I'm going to set my 0. Basically, I'm going to start over. Lost where I was. So I've got my 0 set on the back side. I'm going to swing it around, and I am about 1 thou out. So I need to Tighten that up a half a thou. I'm going to split the difference. I'm going to spin her around to the back side. And I think it went the wrong way. Get my bearings. So now I'm 5/10 thou on the front side, and I am 5/10 thou just a little bit. I'm a little, basically a tenth. So 6/6 on the back side. So check that again. 5 on the front. What I'm going to do is go ahead and zero the machine, zero my indicator. This is easier to tell. So now I'm 0. And yes, 5/10 here. So I need to split that in half. That's a half. I'm going to re-zero. So now I'm 0 on the back side. Come around to the front. And 0 on the back. 0 on the front, I'm sorry. So I'll zoom in so you can see that. There we go. I don't think I'm going to be able to get it to where you, yeah, there. You can just barely see the 0. So we're 0 on the front, and then we're going to spin it around, and you can see we're 0 on the back side. So that tells me that my left and right is good. And once the left and right is good, then I can work on the up and down. Now the trick is to get everything tightened down without moving it. So I'm going to keep my indicator right in place, and I'm just going to tighten the front, tighten the back, bringing everything in back and forth to my 0. And then once it's snugged down, I'm just going to check, and I'm good. And then from there we can go ahead and start checking our up and down, and that's where we want to, on our y-axis this way, basically the nod. And that's where you can figure out what the torque is on your tailstock, how many foot-pounds that you should torque that to. So basically I've got it tightened down. I'm 0 on the top, and I am pretty darn close to 0 on the bottom. Just a little bit. 0 and 0. I hope you can see that. Let me zoom in. So you can see I'm 0 there. And when I bring it on the bottom, I'm 0 there. I think you can see that. 0 there. So this is in perfect concentricity. The tailstock is now in perfect concentricity to the center bore of the lathe. And then what I would do is I would set this top side just like that. And if I loosen this up, you'll see it fell off 5/10,000ths. So here's the 0. If I release tension on the tailstock, you can see I dropped off 5/10,000ths. So this is how I would figure out how many foot-pounds it takes to bring the tailstock into alignment is basically I would go to torquing my tailstock down from nothing until it comes to 0, and whatever that is, that's how many foot-pounds I need to be torquing my headstock to keep that in alignment with my spindle bore. And you can see that's right back to 0. In the case of this particular machine, that's about 30 foot-pounds. Well, that's pretty much the process I use to true up my lathe. We got lucky, we didn't have to do anything with the headstock in relation to the center line of the bed. Like I said, that's pretty rare. I've had, out of all the lathes I've had 2 that I've had to do that with. One was a wore out South Bend that not mine, but one that I had to bring back for somebody, bring back to life for somebody. And the other was my big blue lathe. And that was just because of the way it was slung up onto the trailer. The rigger that loaded it was in a hurry, and I don't know that, you know, out where I live, he's done a bunch of lathes. So anyway, nothing got damaged, but I had to go through that whole process on that lathe, and it's just another step in the process. It's actually very similar to how you do the tailstock. That being said, if you have a new machine, you're going to go through and true it, and then you're going to want to check it again in 2 weeks. This machine was just fine. You know, I kind of had to sabotage it a little bit here and there to be able to show you some stuff. Outside of that, if you're just turning parts, you're pretty much good for 6 months to a year, depending on your base. If you're in an area of the country that's you got a real sandy base, you may have to check it more often than that. But for sure, anytime I do action or barrel work, I check it. It only takes, it doesn't take very long once the initial truing is done. Pretty much after that, all you got to do is make sure that the bed is leveled, because the only way anything else is going to get out of adjustment is if you knock the thing over, you crash it, or you get a temperature change, or the ground settles and it puts a twist in the bed. Once you take that twist out, everything should be brought right back into alignment. But for sure, I check that every time I do an action and barrel. One thing I'll say on that note is, if I know I'm not going to finish the whole project that day or in that moment, i.e. the action, get the action trued up, and then get the barrel in there and cut the tenon and do all those things. I'm going to break it down into steps to where I'm not, like for example, if I know that I've got time to cut a tenon, but I'm not going to have time to do the chamber work, I'm not going to do any of it. I'm not going to leave a barrel chucked up in the lathe knowing I'm not going to get to it, because tomorrow it might be different than it was today, especially down here with the temperature swings. I don't have this shop completely insulated yet, so when it gets cold, it gets real cold. When it gets hot, well, not real cold, but it gets cold. When it gets hot, it does get real hot, and that temperature change can dimensionally alter your equipment. So I'm only going to do the work that I can get done in that run. And then whenever I can get back to it, I'll just verify that my lathe is true and then go about my business. And to be honest, I kind of double check some things throughout the process anyway, just to make sure. But that's an upcoming video. So from here, I think what we'll do is we'll cover some basic lathe operations. In the next video, we'll do some facing, some turning, some threading, probably some parting, some drilling, some boring, and then we'll probably make our first tool, and it's a tool that you'll use, especially if you can get your lathe as true as this, what we'll probably do, I think I have it on my bench. This is a project I'm working on for a friend of mine. This is a reamer holder. They're pretty simple to make. This one is a fixed reamer holder. There's no float to it. I'm thinking that we'll either make this or attempt a. I've made a floating reamer holder. It has and it works real well. If you like the video and you have a preference on what you would like to see, drop it down in the comments, floating or non-floating, and we'll see what we can do. The non-floating is certainly a lot easier to make. That'd be a good place for a beginner to start to some degree. It's complicated, but we can do it. The floating reamer holder, there's a lot more to that. But drop a comment down below on what you'd like to see. Anyway, thanks for watching. If you found value in this, please feel free to hit that like button, and don't be afraid to subscribe. Hopefully I got some pretty cool stuff coming up down the road. Other than that, we'll catch you next time.